Everyone, in this video, we are going to begin chapter 8, our final chapter. We're going to talk about the line of best fit today. So chapter 8 is about two variable data analysis. We are going to look at the relationship between two variables, two sets of numerical data. And this chapter is important for your culminating activity. So it's important that you understand the concepts that are being taught in this chapter. Okay, let's reintroduce the scatter plot. Now, remember when we learned about graphs back in chapter 5, we quickly looked at the scatter plot. The scatter plot is a graph that shows the relationship between two variables. So each point here is what we can call a data point. And the data point has two numerical data values. And in this case, one number, the x value, is the temperature, and the y value is sales. So for example, this point right here, this can be around 25 for 25 degrees, and it's probably around 620 or $610 in sales. All right. This point right here, this point could be maybe 18.5 and 410 maybe. I'm kind of estimating here. Okay, so the scatter plot helps us show the relationship between the two variables in the sense that we can see as one changes, how much does the other variable change, if it changes at all. Is there a relationship? Like when one goes up, does the other go up? And when one goes up, does the other go down? Now, we can illustrate the relationship by drawing a line of best fit. There are different ways we can check for a relationship. The most common one is a line of best fit. It checks to see if there's a linear relationship. Okay, it's a line of best fit, and it tells us if there's a linear relationship. So a line of best fit, there is a mathematical way of doing it, which we'll learn using Google Sheets or Excel. But if you had to sketch one, your line of best fit should pass through as many points as possible, and you should have about half of the points above the line and half below the line. And we should draw a solid line for continuous data or a dashed line for discrete data. So here we have a line of best fit. As you can see, it goes through quite a few points. We have just around maybe 4 points below the graph and 4 above. So this is considered a good line of best fit. Now remember, again, if you use software like Google Sheets, you'll be able to get an exact line of best fit. And the formula behind that is quite complicated, but we'll learn how to use it. Okay, so the line of best fit tests to see how strong of a linear correlation there is, meaning how strong of a linear relationship it is. How close can the data points match the line? So some simple examples of linear correlations. If the price of apples is $2 per 100 grams, there is a linear correlation. Every $2 increase in price will lead to a 100-gram increase in the weight. So $4 should give you 200 grams, $6 should give you 300 grams, etc., etc. Now, the other one, if you're walking at a constant speed, then the relationship between distance and time, assuming you're going in the same direction, is linear correlation, right? If I walked 6 kilometers per hour, after 1 hour, I will have walked 6 kilometers. After 2 hours, 12. After 2.5, 15, etc., etc. Okay, so in real life, some variables can have a close linear relationship, but it wouldn't be exact because there may be other factors affecting your relationship. So we usually do not get a line of best fit where the points fit perfectly on the line. We can measure how strong the relationship is, how close the points are to the line, by using a measurement called R, which is the correlation coefficient. The correlation coefficient is a value between -1 and 1. If it's between -1 and 0, that's a negative relationship, obviously. That means when one variable goes up, the other one goes down. Or when one goes down, the other goes up. If it's between 0 and 1, there's a positive relationship. So that means when one goes up, the other one also goes up. The closer you are to -1 or 1, the stronger the relationship. If you have R equals 0, or very close to 0, that basically means no relationship. Okay, that means the points are basically scattered around all over the scatter plot, and you cannot really draw a line of best fit that is anything close to getting the points to the line. Now, the math behind this is a bit complicated, so we're not going to talk too much, but sometimes you get r squared instead of r. So the reason why that is the case is that this is kind of like the relationship between variance and standard deviation. The variance, remember, is the sum of the squares that the data values are from the mean, right? It's the same, and then we have the standard deviation, which is square root of that, because we don't want a squared unit. It's the same reasoning here. R squared, we have R squared because what R squared basically calculates, it's a measurement of the squares that are formed from the distance from the line of best fit to the point. Okay, so kind of like this, if that makes sense. Okay, so if we want to get R, we're going to get the square root because we don't want a squared unit. Okay, so we can use R or R squared. Usually we're focused on R, but in Google Sheets or Excel, they give you R squared. Okay, let's look at some simple scatter plots and examine the line of best fit. Okay, so here for the first graph, we have the age of a tadpole. A tadpole is a baby frog, and length of its tail. So what is the relationship here? If I were to sketch a line of best fit, I can clearly see that the points are very, very close to the line. It is also downward sloping. As the tadpole gets older, in general, the length of the tadpole's tail shrinks. So the points are very close, so we can say it's a strong relationship, and it's downward sloping, so it's a negative relationship. All right, what about this one here? Running time on a treadmill. The treadmill is that running machine, and calories burned. If I were to sketch my line of best fit, it's going to look like something like that. Not perfect, but close enough. Okay, we can see the points are kind of close, but not that close. Okay, and we have an upward sloping line. An upward sloping line means it's a positive relationship, and the points are somewhat close. I'm going to say it's a moderate relationship. Okay, so if I have the absolute values between 0 and 0.33, I'm going to call that a weak relationship. If it's between 0.33 and 0.66, I'm going to call that a moderate relationship. Moderate meaning medium. It's between 0.66 and 1. That's a strong relationship. Okay. All right, 2. Let's practice sketching a line of best fit and getting the equation of the line of best fit. So I'm going to sketch a line of best fit. Let's follow the rules. Try to have it go through a good number of points and have a fair, more or less equal number of points above and below the line. So my line can look a little something like that, maybe. Don't worry too much about making it exact, okay? As long as you have a good general sketch, that's fine. I have an outlier here. I can ignore it. There's probably a reason for that being an outlier there. So my y-intercept, remember the equation of the line is y equals mx plus b. This is the y-intercept. This is the slope, which is the difference between any two y values over the difference in any two x values for the same points on the line. So my b here is 8, more or less, and my slope, I'm going to pick a couple points. Let's say I use this point right here and this point right here. So my first point, it's 20, and the y value is 20, and for the second point it's 14. The x value, I have 11 for one point and 5 for the other one. So I'm going to have 6 over 6, which is around 1. It should be a bit higher than 1, but in this case I got 1. Don't worry if you get a slightly different answer, we're just estimating here. So here I just have y equals x plus 8, which isn't, I would say that's not very, my slope is a little bit off, but the general steps are correct. Okay, so you can try it yourself. You should get a number probably slightly, somewhere between maybe 0.75 and 1.25, maybe a bit higher, a bit lower. All right, now we can get an exact answer for the line of best fit and the correlation coefficient. So for the line of best fit, y equals mx plus b, m being the slope of the line, it's found using this formula right here. It takes quite a bit of time. Remember, this is the sum for notation. So when I say the sum of x, y, that means the sum for each data point that has x, which should have x, y, and y value, you multiply them. Okay, you get that product and you add it all up for all the data points. Okay, here's the sum of all the x values and the sum of all the y values. You multiply them together. N is the number of data points. Okay, number of data points. Okay, and then we get this over n times the sum of the square of the x values minus the sum of the x values squared. Okay. It takes quite a bit of time if you have a lot of data points, but as long as you punch in your numbers correctly on a calculator, you should get the right answer. The y-intercept is found by getting the mean of the y values minus the slope, so you got to get the slope first, times the mean of the x values. And that should give you an exact line of best fit. Now for the correlation coefficient, R, I have the number of data values times the sum of x, y, okay? You multiply the x and y values for each data point, minus the sum of the x values times the sum of the y values, all over the square root of the number of data values times the sum of x squared, minus x, the sum of x squared, and that's going to be times the same thing before y, okay? N times the sum of y squared minus the sum of y squared. Again, it takes quite a while, but as long as you plug in the numbers correctly, you should be fine. What I like to do is, if I have to calculate manually, is for each one of these, I like to calculate them separately. Okay, you can write them on the side somewhere. Okay, write these on the side, and then just do your calculations, and then you can plug numbers into the formula after you've done all these sums. Okay, that's pretty much it. It's a very quick introduction to the line of best fit. Okay, it's important that you know the basics, what the line of best fit represents, what is the correlation coefficient, how we can determine whether there's a positive or negative relationship, whether it's a weak, moderate, or strong relationship. Okay, and you can give these practice questions a try and do the assigned textbook questions for homework.